Hello students. Today's our topic is equations of motion in class 9. This is your first chapter in motion. Chapter 1 in physics, that is motion, and class is 9. What are the equations of motion? Before starting equation of motion, I told you about distance, displacement, velocity, acceleration, retardation, velocity time graph, distance time graph. In these equations of motion, we include all those things which I have told you earlier. Then how many equations of motion? They are base of physics, or these are base of motion. There are three equations of motion which are known as equations of motion. Then always remember there is no one or two equations of motion. There are three equations of motion. In those equations, we relate initial velocity, final velocity, acceleration, distance, and time, and prove of those equations of motion by the help of graph. That is the graph between velocity and time. Now the equations are three equations. First one is v is equal to u plus at. First equation of motion is v is equal to u plus at. Second equation is s is equal to ut plus half at square. Third one is v square is equal to u square plus 2as. Again I repeat, all these equations are known as the equations of motion. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. What is v? Here v is final velocity, u is initial velocity, a is acceleration, t is time, s is distance, u is initial velocity, t is time, half is a constant number, a is acceleration, t is a time. Here the square of only time, not a whole square. This is only square of time. You have to always remember a is not having a square. Therefore, we always take t into times, not a. Third one is v square is equal to u square plus 2as. V is final velocity, u is initial velocity, 2 is a constant number, a is the acceleration, s is a distance covered by the body. Let us consider the body having initial velocity u. After t time, it gains final velocity v during time t. During this time, the distance covered by the body is s and acceleration of the body is a. Then we can prove the first, second, third equations of motion. This theory is always same in all three equations. Let us consider a body is moving in with initial velocity u. After t time, its velocity will be v. During this time, the acceleration of the body is a and the distance covered by the body is s. For derivation, for prove the first equation of motion, here we use derivation of equations of motion. First I use first equation of motion. This is the derivation of first equation of motion. The graph is always same. The graph is between velocity and time. Velocity is always along y-axis. Time is always along x-axis. The graph starts from A and ends at B. This AB graph shows the slope of the graph. Slope is always mixed with the horizontal line, and theta is a slope which represents the acceleration of the body. Let at A point initial velocity of the body is u. Here the graph is not starts from origin. Therefore u is not equal to 0. There is some initial velocity. Let me take this initial velocity as a u. Find the graph will be in at B point, then the final velocity at B point is v. Means final velocity of the body is v, initial velocity of the body is u, and what time velocity changes from A to B? A to B, this graph, and this is the time. The time taken by the body from initial velocity to final velocity is t. This t can be represented by AC or ED because AC is parallel to ED. Then from the definition of acceleration, we can write that acceleration is a rate of change in velocity with respect to time. What is rate of change in velocity? The formula is A is equal to delta V upon delta t. Here delta V, what is the change in velocity? Final velocity will be d to b. Final velocity will be bd. Initial velocity is from E to A or D to C. Both are parallel to each other. Then initial velocity is from D to C. Final velocity is from D to B. Change in velocity between these terms BD minus BC. Time, change in time is ED or AC. The change in time is ED or AC. Putting the values of BD and BC, we get V minus U upon T. Substitute the value of BD and BC, we get A is equal to V minus U by T. By cross multiplication, A into T is equal to V minus U, or V is equal to U plus AT. V is equal to U plus AT. This is our first equation of motion. Then this proves the first equation motion by the graph between velocity and time. Now in another video, I told about the derivation of second and third equation of motion by the same graph. Okay, thank you.